Okay, so this video we're actually looking now at using the circle theorems in action. And again, like I said in the previous video, if you've done this with me in class, like we know the actual questions on this can get a bit more tricky because you've actually got to kind of work out what the question's on about. So what I've done is I've just chosen 4 exam questions, right, on circle theorems that are going to hopefully sort of test your knowledge on circle theorems. So definitely, right, if you didn't watch the previous video on circle theorems, I would watch that because that just goes through the basic rules, the basic theorems. But this video is actually like looking at applying them. Let's get into it. So what you can do is I'll go through each of them individually. So you can kind of pause the video at each of them, give them a go if you wish, or if you get stuck, you can always rewind it, go through it with me, whatever you want to do. Okay, but let's make a start. So we've got B, C, and D are points on the circumference of a circle with a center O. Okay, and again, I always say with questions, often they give you loads of words, which a lot of people, including myself, can find quite hard to process. But it's just already on your diagram, right? We can see that B, C, and D, right? These are clearly points on the circumference. So that is fine with a center O. It's just telling us what's already on the diagram. And we've got AB and AD are tangents to the circle. Remember a tangent, and that's a pretty key thing going on here. So AB and AD, so this line here and this line here and AD, right? These are tangents to the circle. So what does that really mean? Well, it means, and this is going to be useful to us, that a tangent and a radius, they meet at a 90-degree angle. That is one of our circle theorems that we looked at on the previous video. So if they tell you some information, right, it's probably going to be useful in that sense. And we've been given the angle DAB, the middle one, A, is your angle 50, which is already labelled on our diagram. Great. Work out the size of angle BCD. So we're trying to find angle BCD, where C is the middle one. So we're looking at B, C to D. So we're looking at finding this angle here. So the more you do of these, the more you'll be thinking, right, okay, this is actually using another theorem, okay, which is that the angle at the center, so this angle is going to be double the angle at the circumference. So if I can get this angle, I can get this angle using another circle theorem. Right, so actually, by not even reading the question, well, I've read the question, but by kind of writing down step by step what the question has given me, I've got some pretty useful information, right, because I now know, right, I've got a quadrilateral. Okay, so these 2 dotted lines plus this one here, plus this one here. Okay, I know the angles in a quadrilateral add up to 360. So, and it says give a reason for your working at each stage. Right, so let's go and work out angle, let's go call it angle DOB. So let's work out angle, and this means angle DOB. No, I could have called it angle BOD, it doesn't matter, as long as the O is in the middle. Because to get this angle now, I can do, right, 360, because angles in a quadrilateral, a 4-sided shape, add to 360, this yellow shape I've got here. Take away 90, take away another 90, take away 90, take away 90. Also take away that 50, okay, is going to be equal to angle DOB, which is what I want. So if I go and put that into my calculator, right, 360 take away 90, take away 90, take away 50. Right, that is equal to 130 degrees. Okay, so this angle here, angle DOB, again, this symbol just means angle. Okay, some good notation. This is equal to 130 degrees. And it says state a reason, so I should really probably say, you know, this bit, angles in a quadrilateral, sum means adds up to 360 degrees. Okay, and also state a reason at each stage. Well, we should probably also say that here, a tangent plus a radius, right, they meet at a 90-degree angle. Okay, just being really sure that we're getting all the marks there. So now I'm trying to find angle BCD, which is this one over here. And that is using another circle theorem, okay, which is the theorem that the angle at the center is double the angle at the circumference, which must mean that this angle, so angle BCD, the one that I'm after, angle BCD, where again the middle one is the one that you're after, BCD, must be equal to 130 divided by 2, 130 divided by 2, which is going to be equal to 65 degrees. And the reason is, right, that the angle at the circumference or I should really say at the center, angle at the center is double the angle at the circumference. Okay, so there we go. That is our answer. Okay, angle BCD is equal to 65 degrees, and I've shown the working at each stage. I've been really, really clear with it, hopefully. Right, angle DOB originally in this quadrilateral, this yellow shape here. And then from there, I got angle DOB, 130. This angle is half of that angle using this theorem over here. If you got that, fantastic. Good, really good. Okay, question 2. I've got A, B, C, and D are points on the circumference of a circle, which I can already see with the center O. Okay, and really, right, with these questions, you're looking at, well, what rule straight away can I maybe just spot here? Okay, that's what I'll be doing. So just by looking at this thing here, I'll be thinking, okay, that's that kind of one, the shape one where I've got this kind of this thing, so angles from the same circumference, this one going on, drawn really, really badly. Okay, but I can recognize that one. That's one of my rules, but also I've got my sort of triangle in my semicircle. Okay, so that is going to be another rule useful for in a second. Anyway, we'll keep reading with the question. It says, BOD is a straight line, which we can see. Angle ACD is 62, which is also on the diagram. Find the size of angle ADB. So we're looking at angle ADB. We're looking at trying to find this angle here. Okay, which we're just going to go and call. Let's leave it like that. We're trying to find this angle here. Well, where can I begin with this? I'm thinking, right, we can get, and it says give a reason at each edge you're working. Right, this angle here is going to also be equal to, so that angle there, we can say is angle something like ABD. So angle ABD must be equal to also 62 degrees. No, you could have called that something like angle DBA. It doesn't matter as long as the B bit is in the middle. And the reason that these two are both 62 is, and we've got to state the reason, is because angles from the same arc, okay, because these angles, they both come from this same arc, which is down here. Okay, so angles from the same arc at the circumference are equal. Okay, so we need to know these circle theorems off by heart, okay, to state them in the exam. So that's useful, right? And I'm spotting, okay, I've also then, which we highlighted just a second ago previously, really, right, I've got this sort of triangle here, okay, which is going to be definitely useful. So I've got this triangle also here, okay, not drawn in particularly well, but there we go. And actually, this is using another circle theorem, which is saying angles in a semicircle contain a 90-degree angle, which is what I've got here. So if I go and consider triangle ABD, so if I'm looking at triangle ABD, well, to get the missing angle here, which is what I want, I can just do 180, that's what my angles of triangle add up to. Subtract 90, subtract 62 will give me my missing angle, okay, which is going to be equal to, whatever it's equal to, 180 take away 90, take away 62 is equal to 28 degrees, okay, and that there is going to be my answer. But I've got to state also, okay, to make sure I get that extra mark there, the reason for this, and again, my reason is angles in the semicircle, so that blue thing I've highlighted, angles in a semicircle contain a 90-degree angle. Okay, and that should be good for all the marks. Okay, so it's, you know, when you see these questions, you're kind of spotting, right, what can I potentially use, what theorems can I use, and then you kind of work from there. But they come with practice, right, because there's a lot of different variations they can ask with these questions. Okay, questions 3. A, B, C are points on a circle. CD is a tangent to the circle, which we can already see on the diagram. Work out the size of angle X, which is this one here. Well, it's only a 2 marker, this question, so not going to be much working. And actually, it's just going to be the alternate segment theorem, which just states the angle from between a chord and a tangent, so this stuff here, is equal to the angle in the opposite segment, which is this one here. Sorry, in the alternate segment, which is this one here. So I'm just going to be saying, right, that angle X is equal to 65 degrees, which would get me 1 mark, but I've got to give the reason for the second mark, and you just have to state, right, because of the alternate segment theorem. Okay, and that would get you the second mark there. And that's it. Question 4. Okay, what is happening with this question? Again, right, before even I'm reading the question, I'm just thinking, what can I potentially see here? Right, they've given me another tangent, which is here, okay? And I've got another chord, which is here. And I've been given this angle, so I can actually go and use the alternate segment theorem again to get this angle up here, which is also going to be 39. So, right, what you'll do with these questions, you're going to be spotting, right, what can I see in a question? And then you can go from there, really, because often, right, you give them the question, but again, it's already on the diagram for you. ABC is a tangent at B, already drawn on there. Angle ABD is 39. I can see that. Angle EFD is 18. I can already see that, right? Work out angle BDE, which we're looking at BDE. We're looking at finding this whole angle here, BDE, where D is the middle one. Okay, I've also just spotted, right, in this question that you've got a cyclic quadrilateral. So you've got a four-sided shape within your circle, hence the cyclic part. So this bit, this bit, this bit, and this bit here. So I know the opposite angles in a cyclic quadrilateral add up to 180, which must mean, well, this angle here, okay, must be equal to 180. Take away 18 plus 39, which is equal to 18 and 39 is 57. So take away 57, okay, because 18 and 39, right, so that's going to be equal to 180, take away the answer, which is 123. And I didn't give it any of the reasons here, so I need to. Right, I need to say that this angle, it's going to be formed like this. Angle BFD will do. So angle BFD is equal to 39 degrees, right, because of the alternate segment theorem again, which is nice. And over here, this angle, so angle BDE, which is the one that I'm after, so angle BDE is equal to 123. And the reason is, right, we've got opposite angles in a cyclic quadrilateral sum add up to 180 degrees. Okay, so that is our answer, right? Stating all of my reasons as I go through, and there we go. Okay, that is my answer, 123. Okay, which I'm going to write down here also to make it hopefully a little bit clearer. So 1, 2, 3, that is my answer on this one. Look, with circle theorems, there's so many different variations that they could ask, right? And they can be quite sneaky with what they ask in exams. It's just, you've got to really practice these, right? So get as many exam questions on this topic as you possibly can, and you've just got to go through them, because you've just seen there, right, 4, I would say, quite different examples. I would say these are like medium difficulty. They can get really, really quite tricky. But I'd say these are quite tricky. These aren't particularly easy ones, but they can make them really quite complex. Anyway, hopefully that was useful, and then on to the next video. Thank you. Sorry, if you want to mark your work again, right, answer 1 was 65, 2, 28, 3, 65, and 4, 1, 2, 3. I should have really highlighted that one there. Okay, thank you.